Good morning, good afternoon, or good evening, depending upon where you live around the world. Status of the dome hub. At the moment, I'm going through the possibilities of which hub I want to take more seriously for my project. My preference was certainly the solid hub with the angled sides, because that created a square cut to each strut. But the complexity of achieving it started to weigh on my mind, and I was thinking, well, yes, they can be built, obviously, but most of what I'm trying to do is have a design that's able to be built by me or other people that wish to build a similar structure. The benefits of the hubs, or each different design, they vary. And while I actually prefer the one that's in front of us in red, with the solid centre, tube centre with the wings on each side, the complexities of achieving it well and easy within a home workshop, you'd need to be an engineer with knowledge and skills and tools to set it up well. In the process of looking at how I would perhaps set it up, I've got what would be a metal plate on the bottom, preferably a metal plate, with these circular items here are actually representing for me a bolt where I could screw it in and out to give different heights, because each of the wings have a different landing point, and where this one would touch the base plate, these ones here would have to be 12 millimeters up, and these ones here might have to be 14 millimeters up, and a thread in the base plate means that I can dial them in off of the specifications I've created from within my SketchUp drawings. To achieve the squareness, I can use a welder's magnet to attach to the metal plate, and it would hold the wing at 90 degrees. And of course you could always check it with the inclinometer that we see represented here. But it gets more and more complex if you, and one of the things was these would be okay if you're doing mass production. You could change how you build them, but for one-offs you don't want to have more of a complex process to build the hubs than the whole dome itself. So we've got to think of the practicality. The height or the angle that you'd create would be from this item here, another bolt that could be screwed up and down, and of course the angle has to be very specific, hopefully to the 10th of degree, and all of these things started to become a little bit involved. Having this on a particular angle isn't necessarily reliant on these screws being in the correct height or orientations, because you could use the inclinometer on the actual wing itself and get the angle, but they need to be held for the welder. Another process, if you want to build it yourself and weld it yourself, and you're capable of doing that, well, all well and fine, but again, it may be that you need to get another person in to do some of the work, i.e. the welder. As I mentioned, this is my preferred option, but again, the same issues of holding these in the required position and angle started to become a bit more demanding. I think, in fact, once you've got the measurements and the metal cut correctly, which is an issue unto itself, it would be easier to build than this version. Then I thought, well, we can make it a little bit easier by having all the surfaces on the wings coming to a common point at the top and bottom, and any discrepancies are within the timber itself. If you've got a 100 mil piece of timber, as represented by this, 100 mils deep, you make these slightly narrower, so any discrepancies that we do know will exist from the surfaces would just be something that you would have to tolerate within your dome. And it also means that there may be a bit of fudging where you put the height of these relative to your wings. Not necessarily desirable, but maybe more practical. And then I went down the route of how we could build a simple dome, or it's a hub, a template or jig, and we started to come up with this, which is an extension of the one in the background here. And I thought, well, maybe we can design them upside down. They can be held in place by a slightly larger plate, which, you know, this part of the jig, not part of the hub, so that the acute angle of this bit of plate can be pushed up against this large washer, and that would help to orientate or locate the wings. And then I went back to, well, maybe we just go to the star plate type plate, and how do we achieve that? And in the end, I'm coming towards the star plate approach, that you can create the geometry and drawings within SketchUp, bang it off to a laser cutter, a company, they do the hard work, and you wind up with this, of which you then can bring across to your little jig, and you can bend the lugs, the wee plates, to whatever angle you want, because you've got your inclinometer. So if that had to be down to the 10th of a degree, this goes down to a 100th of a degree, getting a wee bit fine there. But if you've got the ability to do this and get them cut, they're going to be exact down to the laser company that I use. They say they go down to 0.2 of a millimeter accuracy, and I've had work done by them before, and yes, they are pretty good. And by doing this, for a one-off, you pay the money up front to get them made, you get the required number, and away you go. I think at this stage, for me, this would be the preferred method. I'm going to do a couple of variations of this for where they are located. I've noted that some people use a 3mm steel plate. I think that's too light for my way of thinking. I'm looking at a little bit thicker here, 5mm, but they're saying a 3-meter plate is good for up to 10-meter diameter domes, and I'm thinking, okay, that may be a full dome, not the truncated versions that I've got plans for. And the dome means that all the triangles work together and they come down to the base or the ground, where they can dissipate their forces onto many more points, whereas the pergola cum carport is more, well, it's not a complete dome, is it? So the forces have to go somewhere, and at some point they will go through the hubs. So therefore the hubs have to be, in my view, much more stable and robust in the version I'm looking at doing, and I want to cover that off using 2 or 3 different combinations or positions on the struts themselves. So that's where I'm at the moment. I was just going through the thought process of how complicated would it be to jig up the different options, and I'm coming to the conclusion that for a one-off, these sorts of, this hub, the solid hub, the star type hub here off of a central steel tube, there's too much work in it to make it justified, because each point you have to fabricate something precise introduces a potential error. Having to get other external sources involved to do the welding, certify it, becomes an issue. And in the end, I think keeping it simple, getting someone to laser cut them is probably going to be the most economic method to do it. Probably look neater in the end. I do favour these though. I do like them for what they can achieve, but at the end of the day, we'll see what we wind up with this. And the other thing is, you can make mock-ups of these prior to actually sending them off to the laser cutter, just using a light plate and perhaps cutting it out of some thin tin or some such, or even other plastics or whatever that are easier to cut. So just a thought, and that's it. It's a process of trying to eliminate the problems before they become insurmountable or costly. Okie dokie, that's me. I'm off. I'll see you later. Bye.